Hi, everybody.
Hi, Dave.
That was pretty good for this time of day. My name's Dave. I work for New Circle, which is a training organization based in San Francisco, but I am here in Denver. So all those of you who said you were just hiring, if you need to train your new hires, let me know. We can help with that. I'm here to talk to you guys today about coordinator layout, and specifically coordinator layout behaviors. Quick poll of the audience. How many of you have toyed around with coordinator layout yet? Have you tried it? Maybe a teeny tiny bit. Okay, so not too much. It's still fairly new. It was introduced as part of the design support library that they announced at Google I/O just earlier this year. So it's not surprising that a lot of you haven't had the opportunity to really dive in and mess around with it too much. But it's an interesting toy, if you will, that we can play around with. It gives us some flexibility in how we define the way our user interface works and how views interact with each other inside of the UI. So I'm not going to spend too much time today going over the basics of coordinator layout. I think just the simple use cases that Google has set forth for some of the material design patterns that they believe you should use it for, I think they've done a good job of showing you those examples and kind of how to put those together. Now, you may not have any clue why you're putting those examples together that way, but at least they work when you do that, okay? What I'm going to try and do is dive a little bit deeper into that to just sort of try and give you an idea of how these interactions between the views actually work, so that hopefully when you're either looking at their sample code, or if you want to do something crazy and try and extend these behaviors to do something that the framework didn't necessarily give you out of the box, that you have some amount of control and some idea of what you're looking at when you're going through some of that stuff. Okay? So that's kind of where we're headed as we go through this. So what is coordinator layout, since not a lot of us have played around with it? According to the documentation, yes, this is in the documentation, coordinator layout is a superpowered frame layout. Okay? That doesn't mean a whole lot in and of itself, but effectively what it is it's a container view that you can put other child views into, and in addition to just laying them out like you would typically do with any traditional layout like linear layout or relative layout or frame layout for that matter, you can define additional rules that apply relationships between these views. And this is something that is brand new, we've never really had before. Many of us who have been doing Android development for any amount of time have probably written something like this at one point or another to accomplish some of these same goals. And now it's being provided to you in a more extendable fashion. Okay? So visually speaking, coordinator layout allows us to do interactions like what you see going on here. So the common interaction of the toolbar sort of scrolling away when you scroll up but then returning back when you come back down. Or when you hit the action button, a snack bar comes in and that button sort of moves out of the way and then slides back down when it's gone. Right? So those are two simple examples, but the idea that we have multiple views together in this container and they need to act together in some way. So I scroll, in this case, the recycler view, and the app bar goes with it. Right? When I see a snack bar come in, the floating action button moves out of the way and slides along the same path. Okay? These are things that we could have done before, but would have to write a significant amount of code to accomplish, and in most cases, most of us would just ignore it completely. Okay? So coordinator layout allows us to define this behavior, and the behavior you're looking at is the sort of thing that they give you out of the box. Okay? So where I'm going to start is sort of giving you an example of what they have for you, and you can sort of get an idea of how those things interact, and then we'll sort of move from that into how you could customize this yourself. So if we're looking at this example that's continuing to animate here on the screen, I mentioned that the way that coordinator layout assists us is it allows us to define these rules, which are often also referred to as behaviors, that establish relationships between these views. Okay? So inside of the example that I just showed you, that coordinator layout has a handful of views inside of it. Right? It has the recycler view, which is the thing that was scrolling up and down. The app bar layout, which is a specialized container that's essentially designed to wrap a toolbar. Okay, so action bar, toolbar, you stick them in one of these things so coordinator layout can control it. That's really the only reason it exists. The floating action button, everybody who knows material design knows and loves that thing, the little circular button down there. And this additional layout that gets temporarily added and removed from the view hierarchy for that snack bar, okay, popping up from the bottom and then coming down below. So we have all these views in the container, but what coordinator layout really does for us and where it starts to shine is as we're building this, it allows us to define these relationships that are called behaviors. Now, a behavior is attached to a view inside a coordinator layout and is then used to define one or more relationships between that view and other what they call sibling views around it. Okay, that just means other views contained in the coordinator layout. Okay, so any given view can have one behavior attached to it. Okay, but that behavior could define how this view reacts to multiple different views. Okay, so for instance, with the recycler view, there is a behavior attached to it in that example that I showed you where it is reacting to changes in the app bar layout. And it turns out, conversely, there's actually a behavior in the reverse direction where the app bar layout is looking at the recycler view as well. So we've actually got this circular dependency thing going on, but they're used for different reasons. Similarly, the floating action button actually has a single behavior that reacts to two different views. And I'll talk about this more a little bit later. The only one we've seen is how it responds to the snack bar moving in and out. But it turns out that the floating action button actually reacts to the app bar layout as well. Okay, so that single behavior can create a dependency or a relationship between the view it's attached to and multiple other views in the same container. Okay, so the question is, what can we do with that? Right? There are some standard behaviors given to us in the framework that allow us to accomplish those simple goals like scrolling bars out and moving buttons around. But can we go further with that and make our own behaviors to do all kinds of crazy stuff? And the answer is yes, once we understand how the API works. Okay? So behaviors are attached to views. I mentioned that before. There are two ways in your code that you can attach a behavior to a view. The first is using this annotation. So if you define your own custom view, whether it's a custom widget like an action button, or maybe a custom container view like I have here as an example with this footer bar. This is essentially how the app bar works as well. You can declare that there is a default behavior using that annotation that should be attached to this view anytime that view is present in a coordinator layout. Okay? So you can add this in your Java code if you're building a custom view and you never have to manually declare that every time I add this view I use this behavior. They're just always paired together. Okay? This is used quite a lot. Most of the material design support components in the support library have their own default behaviors defined in this way. The floating action button, the app bar, all the pieces that I just described before. So this is one method for doing it. The other option is to do it in XML. So when you build a layout with a coordinator layout as the root, all the child elements inside of them, if you don't want to use the default behavior for that view, or maybe one doesn't exist, you can explicitly attach a behavior to a view using the XML tag. Okay, so in my layout, I can declare this layout behavior and tell it the class name of the behavior I want to attach. Okay, so this is a one-to-one relationship. Every instance of a view in the coordinator layout has a single behavior associated with it, but I can do it in Java code or in my XML layout, whichever suits your purpose. Okay. So that's just the use of the API. That's true whether you're using the existing behaviors or building your own. But based on that, let's take a look at how we could construct our own simple behavior to do something completely different than what the framework provides us instead. Okay, so if you want to create your own behavior, you basically just create a new class that extends the coordinator layout behavior. Now this is typed. And it's supposed to be typed to the type of view that this behavior is going to be bound to. Okay, you can sort of negate this if you want. You could just set this to view, and you could attach your behavior to anything you want. But this is intended to clean up some of the later API methods that you'll see a little bit later on by bringing in types of the view that you're attached to, so you don't have to do casting and other messes like that. So when possible, especially if that behavior is only associated with a specific type of view, you would put that type in here to clean up those callbacks a little bit later on in the code. Okay. Now there are two types of constructors for building a custom behavior. There is the default constructor, which takes no parameters. This is the one the framework will use if you supply that behavior as part of the annotation. So if this is considered a default behavior for some view type, the framework will use that constructor to create the instance. If you don't override it, you'll see an exception when it tries to inflate your layout, because that constructor will not exist. Similarly, if you want to attach it in XML using the second method that I showed you, in that case, you need to override the constructor with the attribute set, right? Just like any other custom view constructor if you've done any work with custom views before. And again, same problem. If you forget to add that and then you try to attach your view or behavior to a view in XML, it's going to crash and you're going to know right away that you have the wrong constructor. Okay? So if you're not even getting past attaching a blank behavior to a view and it's crashing, this is probably why. You forgot to add the right constructor depending on how you were attaching it. Okay. A lot of times these constructors don't actually do anything, although you could use them for initialization. Usually they're just going to be empty and you'll do everything later on in the code. Okay, so I like to break down coordinator layout behaviors into two primary subgroups. If you just look at the documentation for a behavior, there's a pretty large number of callback methods that if you just look at the list, it can be a little daunting to figure out, well, where in the heck would I actually put this type of code depending on what I want to do. So if you break them up into a couple sections, it's not so bad. The first type of definition that I refer to is a layout behavior. So these are behaviors similar to like the ones I just showed you in the example, where the floating action button moves its position based on the position of another view, right? So based on the size and or position of other views around it, you want to control the size or position of a specific view, okay? So you want to control its layout parameters. It's kind of where the name that I came up with comes from. So the primary method associated with this when you're extending your behavior is this layout depends on callback. This is the method you use to define the relationships between your view that you're attached to and the other views around you. The coordinator layout will call this method on the attached behavior for every other view inside the container and basically ask you, do you depend on this one? Do you depend on this one? Which one of these views do you want to establish a relationship with? And you're responsible to determine either based on the type of view it is or maybe the specific instance if you have multiple views of the same type, that yes, this is the exact view that the view I'm attached to needs to respond to if it changes its size or position. Okay, so you declare those dependencies by a return value from this method. Then based on where you go from there, the remainder of these callbacks will be triggered at different points in the code. So the nice thing about adding these dependencies is that layout behaviors then get the opportunity to participate in the measurement and layout of that custom view or of that child view. Okay? So the view that your behavior is attached to will have the behavior itself will have the opportunity to be the code that measures and the code that lays out that specific view, rather than relying on the parent view to do that, which is the default behavior. Okay. Now the other nice thing about this is based on the dependency order you declare, coordinator layout will make sure that the views are laid out in the proper order. So for instance, if my view declares that it depends on the app bar, coordinator layout will make sure it lays out the app bar first, so that when I lay out my view, I can rely on that information to figure out where I should place the view that I'm attached to. Okay, so it actually will reorder the measurement and layout paths, which is traditionally just done in child order, which is basically the order you added them to the view. Okay, so you get to control a little bit of that just by moving that around. Now, this is similar to other measure and layout callbacks. These are only really going to be called once, or once every so often when there's a significant change to the structure of the layout. So these are sort of those same initial callbacks. The extra callbacks that are going to be a little bit more helpful for your control are going to be on dependent view changed and removed. These methods are going to be triggered by coordinator layout for every incremental change to that dependent view. So go back to the same example where I'm dependent on the app bar. Anytime the app bar moves or changes size, even a little bit, that is going to trigger a callback through the behavior so that I can modify my view with whatever that information is. So in the example that I had in the animation where the recycler view was scrolling up with the app bar, that's essentially happening because as the app bar scrolls, the recycler view is getting those notifications and is moving along with it. Okay, it's basically saying, oh, you moved, I'm going to move. You moved, I'm going to move, so that they stay in sync. Same thing with the floating action button example. Right, the action button recognizes that the snack bar is moving in from the bottom, and as it moves in, it takes that same offset and moves itself. Okay, and you can see it doing that incrementally, which is why it looks animated and they move together. Okay. Same thing if that dependent view is removed from the hierarchy, you may want to make some change, so you're able to do that as well. Okay. So you can, with just these 5, you can create some fairly simple and useful coordinations in just view size and position. Okay, and this is how most of what they call the quick return behavior works, right? Which is that behavior where I scroll up, it disappears, but as soon as I scroll back down, it comes back into place, right? So that's referred to as the quick return pattern, and most of it is based off of this set of callbacks right here. Okay. Questions on that so far? Yes.
How heavy is this? It sounds like you're doing a lot of. I mean, if you start building some pretty intense UIs, you could really get into some. I mean, maybe not. Maybe it's super fast, but I'd be worried about performance implications of doing all this.
Moving views around is not so bad. And to be honest, even changing their size is not so bad. If for some reason you get yourself into a situation where you're forcing the code to call request layout a lot, then you probably will, because that's going to cause multiple layout traversals on every change. But coordinator layout is not necessarily going to do a full layout traversal just because the dependent view changed. That you'll see maybe a little bit later when you see the examples that the behaviors themselves are responsible for actually modifying the view position and information. So the coordinator layout doesn't have to lay them out again because the behaviors are doing that. Okay. At a minimum, the coordinator layout probably just has to redraw. So, but if you, for some reason, decided, no, I need to call request layout on every single one of these, or did something that did that internally, that might cause problems. So setting a view property or something like that.
I was getting into trouble with that, where I was doing something, and I never even did figure out what it was. I just kept changing stuff, and it was something was calling request layout.
Yeah, and that starts getting you back into this path again, which is not necessarily ideal. So you could, if you find that happening, you could get yourself into trouble. But in most cases, that's not the case. The simple interactions that you see the framework doing, and as well as the examples that I've got, are more about shifting views, which don't force layout changes. And even something as simple as changing its size wouldn't really do that either. Other questions? Yes?
Is on-dependent view change called for like everything, or is it your responsibility to call that from like the scroll listener?
No, it's essentially called for every posted change. So if, for instance, in the app bar example, the app bar is moving incrementally, so anything that depends on it is going to get that callback incrementally as well. There's nothing you have to write to manually dispatch that event in any way. Mm-hmm. Other questions? Okay, cool. So this is just an example. It's a quick example of what you would see if you looked into the source code for the floating action button behavior. So you jump into the support library sources, you go into the floating action button, you'll find its internal default behavior, and this is just a snippet out of that. Okay, to give you sort of a concrete example of what's going on. So, for example, the floating action button, as we saw in the example, was dependent on that snack bar. Right? When the snack bar comes in, that's when it has to move around. So all it has to do inside of its behavior is declare that when the dependency that the coordinator layout is asking about is a snack bar, we say, yes, that's the thing we depend on. Okay. This is a fairly common pattern in most of the framework code. They don't necessarily check specific instances. They just say is that the view of the type I'm interested in. Okay. And that will return true for that one view and not for anything else. So that means that later on dependent view changed is only going to be called on this behavior when the snack bar itself changes. Okay, when it slides into view or slides out of view. Okay. So in the rest of that code, there's a section where they're checking, okay, well, is this the snack bar? And if it is, then update the translation of the floating action button to match. Okay. I don't have that code in here, but you can sort of imagine what it's doing, right? Now, the interesting thing is, I mentioned that in order to declare this dependency, we had to return some value from layout depends on, and that would declare that this behavior is attached with some sort of a relationship to these other views. But in this code, there's this other section here where floating action button actually technically depends on an app bar layout too. But we go back and look at that method, and up here, I never declared that I depended on the app bar. So when on earth would that ever be called? It turns out there is another way that that these behavior dependencies can be created, and it has to do with a feature that's also built into coordinator layout called anchors. Okay? So inside of your coordinator layout, a simple way to define a relationship between two views, if the relationship is essentially that these two views should always be locked together, then you can define that those views should be anchored to each other. Okay, and this is something you would do in the XML by basically just declaring, in this example, which we see all over the place in material design, the example that the floating action button would be anchored to the app bar layout, and it does that by the floating action button saying that its anchor is the ID of the app bar layout. Okay, so you just put that in your XML, and that single definition says that these two views are anchored together. When you do that, the coordinator layout automatically generates that dependency and says, oh, if these two views are anchored together, then whenever the anchored view changes, the other one is probably dependent on it. Okay, and so we go back to this code just for a minute, and so that indicates that now, because the two are anchored together, anytime that's true, which is not always true, in the example I showed you before, they're not. But in that example where the floating action button is sitting on the bottom of that bar and is supposed to move with it, they can define that using an anchor attribute. And when that's done, the behavior will also receive calls for that anchored view, just like it was defined as a dependency inside the behavior itself. Okay, make sense? All right. Jump back up here. Okay, so then if we look at this diagram again, we have a little bit more information to flesh out what's going on here, right? So each of these behaviors that I've just included now, we can start to see where these relationships actually come from. So it turns out that in that recycler view behavior, the recycler view depends on the app bar layout using that method that I just showed you. The behavior defines that relationship in code. But this floating action button that we just went through actually defines one of those relationships in code, but the other one exists if they happen to be anchored together in XML. Okay, but at the end of the day, those both get tied back to that behavior. So the behavior will be called, or those callbacks will be triggered whenever any of those dependent views change. So anchoring or in the behavior, both of them will give you that same functionality. Okay.
And so I'm not clear on what the benefit of one over the other is.
Anchoring has a very specific use case, and so if I go back to here, it's a very specific use case where these two views should essentially be, from their layout perspective, should be considered lockstep. So anchoring basically gives you the default behavior that that button stays on the bottom of that bar by itself. Like that just happens automatically. But then if you wanted to provide additional behavior based on that, then you could do that as well. So maybe a better way to describe that is if I jump back to the snippet of code, notice that in that dependency, we're not updating that the action bar should stay located near the app bar, right? So the anchor declares that for us. So because the two views are anchored together, the fact that when the app bar moves, the button moves with it, that's given to us by default because they're anchored together. Instead, the reason we're paying attention to that dependency in code is to change the visibility of the button. Because it turns out that once you scroll up far enough, the floating action button is supposed to disappear and then reappear when you come back. So there's additional behavior beyond the positioning. The positioning piece is given to us for free by the anchor. So in that specific use case, you would use that. But if the two views aren't actually co-located on top of each other like that, then it doesn't make sense.
Cool.
That kind of make sense?
Makes sense.
Good question. Okay, let me jump forward here. Other questions on that? On this, actually. Okay. All right, so that's one bucket. One bucket is these these layout behaviors that allow us to define these relationships based on size and position. Okay. The other bucket is what I would call scrolling behaviors. And these are behaviors where you can observe scrolling events in a container view that actually scrolls, like a recycler view, and you can respond to those events to do something interesting. Okay. Now, unfortunately, in order to describe to you how scrolling behaviors work, I have to actually take a detour a little bit and describe to you how nested scrolling works, which is sort of an awkward concept in and of itself, so bear with me. But nested scrolling is a fairly new thing. This was introduced to the UI toolkit, to the view hierarchy functionality in 5.0. So some of the functions that you're going to see as part of the behaviors I'm going to describe to you, they're actually part of view group natively now in Lollipop and above. But they also backported this functionality in the support library via AppCompat and other support libraries so that this same behavior could be used on older platform versions. Okay, so we'll kind of see how that plays out. But the idea here is that the traditional touch gesture UI framework is a very top-down system. Okay, I've spoken on that before. There's videos about it on YouTube, right? This whole idea that when you touch the screen, those events are translated down to the views in your hierarchy top-down. So they always come from the parent view down to the child view until they reach a view that's interested in them, and then that view basically consumes all those events. Okay. The problem is, what if you want to create some more complicated behaviors where the parent view is also involved in what's going on with the child view while it's scrolling? Okay. That's the problem that nested scrolling is intended to solve. That even though this view underneath is the one that's doing the scrolling, the parent wants to be involved in that process. It either wants to tell it when it should or should not scroll, or it wants to take part of the scroll and give the rest away, create some more coordination between the two. So the idea behind the nested scrolling interface is to sort of flip that around and say, even though the touch events are still coming down to the child, I want to be able to deliver some sort of a callback back up to the parent so it can participate. That's all nested scrolling is in a nutshell. Okay? It's the methods given to us to be able to do just that. Okay, and I'll talk in more detail about kind of how that looks in a timeline flow. But from the support library's perspective, those are represented by two interfaces, nested scrolling parent, nested scrolling child. Okay, so just like in the example here where we have a recycler view inside of a coordinator layout, coordinator layout implements nested scrolling parent, recycler view implements nested scrolling child. The only reason that's important is because it allows you to do this behavior across platform versions, not just on Lollipop and above. Okay, this same functionality would work with other views on later platforms because it's starting to become native, but through the support library, you can only use components that implement these interfaces. Or you can write your own that implements that interface. If you have any hair left when you're done with that, come talk to me. I haven't done that yet. Okay, so we have these two interfaces that allow us to sort of create this coordination. So the way that this would typically look for a traditional example then is those touch events are still going to make their way down to what we're calling the scrolling child. Just think of it as the recycler view if that's easier to think of in this case. It's the scrolling view. So those touch events are going to come down, but now instead of what would traditionally be the behavior, which is as the user moves their finger, the recycler view is just going to take all those events and scroll. Instead, as soon as it detects that the user is scrolling, the very first thing it's going to do is call back to its parent with a pre-scroll event. It hasn't actually moved yet. It hasn't scrolled anything. It just calls back to the parent and says, hey, there's a scroll gesture going on. This is how far the fingers moved. Did you want to do anything with that? And the parent has the opportunity to take over that gesture if they want. Okay. Now it's a little confusing because the gesture itself never leaves the child view because that's just the way the touch framework works in Android, and you can't change that. But the events, as far as what the user actually sees, can be manipulated such that in a pre-scroll, the parent has the opportunity to say, yes, I'd actually like to take all of that, or maybe I'd only like to take some of it, or no, I don't care. Okay? And you'll see in the API how that actually works out numerically. But that allows the parent to make some determinations before the child actually does any scrolling. And then sort of at that point, the parent returns back some information about whether or not it consumed any of that event. They can consume all of it, none of it, or part of it. Okay? Whatever's left over from this process, the child, or in our example, the recycler view, can use that bit to actually scroll. Okay, so if the parent doesn't care, then the full gesture is going to be used to scroll the contents of the recycler view the same as it's always been. But the parent may want to take all of it, in which case the recycler view can't scroll at all. Or there may be some combination of the two, which in my opinion is where the real power of nested scrolling comes in, where you can actually take portions of a gesture and apply it partly to here and partly to here. That creates some fairly seamless experiences that were, trust me, very hard to write before. Okay. So then after the recycler view in our example has done its partial scrolling, or whatever it's going to do with the scrolling contents, then it's going to call back to the parent again. So the parent, the new bits to this is we have these two new callbacks, one for a pre-scroll event and one for an actual scrolled event. And that scrolled event is where the recycler view now says, okay, I scrolled this far. And it actually will then return back of the amount of the gesture that you gave me, I only used this much. So there may even be some more left over for the parent to scroll afterwards. Okay, so the parent can actually take some before and take some after. And the case where that would be where that would happen is, think of when you're scrolling your recycler view. At some point it reaches the top. If you continue to try and scroll, even though there's no more content to scroll, the recycler view is going to say, okay, I'm scrolling, but I'm not going anywhere. So all of that stuff is unconsumed. So the parent you can use it if you have some use case for it. And I probably won't go through the code, but I have an example showing you how you can sort of leverage that to play around with some different view interactions. Okay? Yes, Mark.
Did you say that consumed tells the child that it's scrolled, or that it's done its part, or?
So in this particular case, this event is essentially the parent saying, this is how much of that scroll gesture I've used up, I've consumed.
Okay.
Could be some, all, or none. Then the child view can use that information to make a determination of how far it should actually scroll its contents. So the parent can take a little, then the child can scroll as much as it possibly can of the remaining. And if there happens to be any more of the user's gesture after all that is done, it's going to kick back to the parent in the scroll event.
Okay.
Does that make sense?
Yeah.
Okay. I understand in words it's a little hard to convey, so it might make more sense when you see it in code, or when you at least see the methods in code.
Is that your terminology that you're using there, or is that?
Yes and no. Like these are the names of the methods. I sort of gave the states names.
Okay.
But yeah, so it's a little bit of both. Okay. Other questions on this? Cool. All right, so back to behaviors. The way that this looks in code is that if you want to implement a coordinator layout behavior that relies on this scrolling behavior, first of all, you need to actually ensure that you have some view in your coordinator layout that responds to nested scrolling. Okay, and that's important because, as I mentioned, not all of the views in the framework implement this functionality. Okay, so I mentioned before that, for instance, list view and grid view, the adapter-based views, don't. Okay, but recycler view does. Okay, so when you're trying to figure out what should I use to scroll my list inside of a coordinator layout, recycler view actually starts to look a little bit more attractive because it's the only one that will dispatch these events properly back to coordinator layout. List view won't do it, so none of this stuff is going to work. Okay. Okay, so the major bits involved here are start nested scroll, nested pre-scroll, and scroll. right? So those are those two states that I mentioned before. On start is just like any sort of initial UI method that you see in the touch framework or anything else, where there's an initial call asking you if you're interested. Basically, there's a scrolling gesture that's beginning right now. The recycler view has started scrolling. That gets dispatched to the coordinator layout, and the layout dispatches that event to all behaviors. Okay, and then the behaviors have the opportunity to say yes, I want scrolling events, or no, I don't. Okay, if you return true, the rest of these methods will be called. If you return false, you get nothing. Okay, just like touch, custom touch, and all that stuff. All right, so on nested pre-scroll, that's the method that will be called at the beginning of each of those scroll gestures, and this is called incrementally, right? So as you're scrolling, you'll get this pre-scroll event multiple times, but you'll get it here before the view actually scrolls. And then you have the opportunity to take the whole gesture or ignore it, or just respond to the fact that it's happening and do something completely different, okay? Which is one of the examples that I have. But at this point, the recycler view hasn't done anything. Then, after the recycler view does its own scrolling, you'll get this callback that says, okay, the view is scrolled this much, and based on the user gesture, there's actually more distance in here if you'd like to do some more scrolling. Okay. The beautiful thing about doing this is you don't have to write any touch handling code. You don't override any on-touch events or anything like that. You don't deal with the motion events or the gesture detection. That's all built into the framework. You're just getting these callbacks incrementally saying this view has scrolled or it's about to scroll. What do you want to do? Okay, that saves you a ton of code if you haven't had to write that before. But I can see a lot of you have. Okay, so in the simplest case, this would be what a behavior would look like that was responding to scrolling events. Just curious, if I say fling, how many of you know what I'm talking about? Most of you. Okay, that's good. So for those of you who aren't aware, basically a fling event is if I've got my device here in front of me and I take my finger and I just go like that. I just fling my finger up across the screen. The behavior on the device is a little bit different, right? It doesn't just follow my finger. When I toss my finger up like that, it animated scrolls up because I basically tossed the list. And it continues to scroll until it sort of decelerates and all that stuff. Even if you don't use an Android device, your device does that, right? So in Android terminology, that's referred to as a fling. So again, the gesture detection is handled for you. And if you want to respond to that type of a scroll event, then there are different methods on the same behavior that you can use to interact with those. Okay, so if a fling occurs, you're no longer tracking individual finger motions because the finger's not on the screen anymore. But you may need to react to the fact that the view is animating in a scrolling fashion and you want to do something because of that. Okay, so there are fling versions of the same methods. Pre-fling and fling, same case, right? Pre-fling is before the fling occurs. And then after the animation has started on the scrolling child, in this case the recycler view, then that's when you'll get an unnested fling. Okay, so you may want to use one or the other. In a lot of cases, you may have to do a little bit of both. In all the examples that I have, I'm using at least one of both of those methods. Okay, so you'll see kind of why in a little bit.
I don't want to get too hung up on the pre-fling thing, but how exactly how does pre-fling anticipate or work with fling? I mean,
Sure.
I can understand how fling works, but I've never heard a discussion of pre-fling.
Of course. So let me go back to this table because that might make more sense. So the idea of really pre-scroll or pre-fling is that that is a state where the gesture detection has already happened, but the view itself has not responded to it. So it's not so much about anticipating that the gesture might happen. What we're saying here is that all the touch events have been delivered to constitute a fling. The user has done this, and we've recognized that they went down, they went real fast, and they lifted up, right? That is the gesture. So we know that happened, but before the view is going to start actually moving anything, before it's going to start animating its contents, it's going to give a call back to the parent to say, all right, I'm about to fling. We know that happened because the gesture's already done. So before I start moving a bunch, would you like to do something else?
It's not in the detection as much as it is really in the process.
Right.
Response.
Exactly. It's in the response, and it's allowing the parent to handle that before the child does anything.
Got it.
So you can consume it so that the child doesn't actually animate its contents, or you can do some action after it has. That's sort of the pre and post state.
Good
Does that make sense?
Yeah.
Okay. Yes, sir.
Hey, do you know an example of something that does this? Because I think I know what you're talking about, and I think I get it, but I don't know if I've ever actually seen it. Like,
Sure. You actually have. So what I'll do, because I'm almost done with the slides themselves, is when I show you an example
Okay.
of even just standard behavior, I'll show you exactly how this is going on.
Okay.
Okay.
Because I know like Chrome, when you scroll up and down, it does the bars move away, but that seems different than the nested scrolling, or is that the nested scrolling?
It's a little bit of both.
Okay.
So, and that might make sense. I'll try to describe it a little bit with a visual app in front.
Yeah, that'd be awesome. Yeah,
Okay. Yeah, definitely.
Thanks.
Okay. Other questions before I move on? Because I'm pretty sure that's actually the end of the slides anyway. So now's a good time for me to show you that example. Yeah, I should pay you for that. All right. So what I've got, let me actually show you this a couple different ways. I have on GitHub. By the way, if you've never seen my GitHub page, it's milehighandroid.com. Oh, of course, I don't have any networking here. So you can go to milehighandroid.com. That's my GitHub sort of front end page. That has all my sample code on it for pretty much everything I've ever written. And on there, right at the top, you'll see a sample called coordinated effort, right? And that is the sample of all my coordinator layout behavior stuff that we're going over right here. So you can either go to my GitHub page, GitHub Dev Unwired, or just go to Mile High Android and you get a link to the repository, which is this sample code. Okay, so that's already there. You can play around with it if you like. So the sample that I've got for you, I'll quickly show you the examples, and then we can kind of dive into some of the code. Okay, so there's 4 examples currently in this sample app. I'll probably add a few more over the months as I have copious spare time. See how that goes. But at least for now, we've got these 4 pieces in here. This first example here is the one that I showed you before with the animation. So the animation that I had with the app bar quick return and the snack bar popping in and out, this is really here as a reference, right? Like if I show you this code, which I will in a minute, there's no custom behaviors at all in here. This is almost copy pasted from a Google sample. Okay, it's just this is the basic behavior you would probably use coordinator layout for your first time through. Okay, but it's a good way to demonstrate that question you had, which is nested scrolling. So just for context, let me jump back up to this slide that I had here. I'll use the one without the colors on it. This slide here. So remember I mentioned before that these 2 views actually have a bit of a circular dependency going on, where the recycler view has a behavior that depends on app bar, and app bar actually has a behavior that depends on recycler view. That's not quite true. What's actually going on is that recycler view does depend on app bar, but app bar is actually listening for scroll events. It's not paying direct attention to recycler view, it's just that that's where the events are coming from. Okay, so it turns out that this behavior, the behavior on app bar layout by default, is listening for nested scrolling events to do this exact thing that we just described. Okay, so let me walk you through it as I'm playing around with it. So the case that we have here is that you may notice that even though this is essentially a frame layout, if you're not familiar with frame layouts, views don't really have any way to place themselves with relation to each other. They're all just kind of stuck in the same space, right? So technically all these views should be overlapping. The reason that they're not, the reason that I have this app bar at the top and the recycler view actually starts here, is because there's a behavior defined that says that the recycler view should lay out below the app bar. Okay, so the recycler view itself, and this might help answer that question, is laid out initially like this. It actually goes down about that far. Okay, and what ends up happening is as I scroll up like this, what you're seeing me do is you're actually seeing me move the recycler view up. It's not scrolling. It doesn't start scrolling until here. Okay? With me so far?
Yes.
Okay. So And then when I do the quick return, it's actually moving down right now. It's not scrolling. Now it's scrolling. Now the reason that works, or the way that works, is if you go into, I won't dive into it real quick, I'll just show you the basics. If you were to look at the source code for AppBarLayout, which is in the support repository, all that stuff, you can pull it up in your thing. The default behavior for that is listening for these nested scroll events. So on nested pre-scroll, nested scroll, so on and so forth. So what's happening during that pre-scroll phase is the AppBarLayout is actually listening for those events, and if the AppBarLayout, or if we're in a condition where it's fully visible and we're scrolling up, for instance, the AppBarLayout is actually consuming those events and saying, no, don't scroll, I'm going to move up instead. But then the recycler view is watching the AppBarLayout and says, well, when you move, I move. So as we're doing this, we're not actually doing any scrolling. And that's all, those events are being captured and intercepted because of pre-scroll. Then once we get to this state, the AppBarLayout stops returning, or stops consuming the pre-scroll. So then the child that originated them in the first place, which is recycler view, says, okay, I can scroll. Does that kind of make more sense, seeing it in motion like that? So, and obviously this is happening all the time because this is what everybody's using CoordinatorLayout for. But the basic idea is I can use the user's gesture to do something like shifting the view, and then later on, based on some condition, in this case when it hits the top, actually allow it to continue to scroll. And the beauty of it, and this is the part that was so hard to do before, is with one single gesture I can do both. Right? I don't have to write any weird code, which I've written before, to try and transfer the motion events from this view over to this view and have this parent view between the two that's dispatching them different directions. It's a mess. Now you don't have to do that. Instead, you can just say, okay, I'm capturing the event until it's not necessary, and then you can just use it. And because this is continuously happening from the same source, we can do it very smoothly. Okay, so the same gesture can manipulate, sometimes scrolling, sometimes shifting, depending on conditions going on there. Make sense? Pretty cool.
So if I assume that bar layout is also implementing the fling, pre-fling?
Yes. Yeah, so I mean, if you come down here, you'll see that they also have the, where'd I put it? There's the fling event. So they're listening for the fling as well, right? And the reason for that is because if I did that, and I didn't implement them, the bar actually wouldn't move, right? Because as soon as it becomes a fling and is no longer a scroll, we stop delivering events to the scrolling methods, they start getting delivered as a fling.
I'm just curious, it seems like the code for both the scroll and the fling would be pretty closely.
Depends on your use case, but in a lot of cases, yes, that's true. In my examples, I think they're almost identical in some cases, yeah. So that's definitely the case. Okay. So if you look at the layout for that simple view that I just showed you, there's really nothing custom about it. Right? I'm not adding any special behaviors or anything like that. The only behavior that's being attached manually is the scrolling, what they call the scrolling view behavior for the AppBarLayout, and that's provided by the framework. Like again, that's something you rip right out of a Google sample. They say by default, the AppBarLayout gets the behavior it needs, but you have to attach the other side of that to your scrolling view, which is your recycler view. Okay, so I didn't write any of that code. The only thing I'm adding is that one liner, which is straight out of Google's code. Okay, so in this example, we're not doing anything fancy. This is just sort of our point of reference. All right, so the other ones that I've got in here are again, fairly straightforward. The first one is what I call a footer view return. It's not too easy to see on this screen, but basically there's another view down here that we've added to the coordinator layout with a custom behavior that is going to respond in the same way as the app bar. Okay, so the app bar moves out of the way when you scroll and then comes back. We're going to do the exact same thing, but with another view on the bottom. Okay, so as I scroll, you can see them both sort of push out of the way. And then when you come back, they both come back together, right? So it's the same quick return idea, but we're applying it to two different bars on both sides instead of just the one on the top. Okay, yes?
So where's your recycler view at? Like you showed it on the last one, how it extended past your screen. but where would it be here? Like, just you tack on the width of the footer view and the app bar layout?
Trying to think of, in this case, I believe it's the same because we're not doing anything fancy with the layout of this. So initially it should be that same spot, which is, you know, kind of down here. And then after it's scrolled all the way up, it's going to sit here. Well, yeah, here, right there. So it'll just shift that distance because essentially as we're scrolling up, if we're scrolling up, the footer view goes away. So there's no worry about overlap. If we start scrolling down again, it doesn't matter that it overlaps. So it doesn't have to scroll above the footer. I actually have another example, not written yet, that I probably want to add that does that very thing. Basically fakes a recycler view footer by sliding one in at the bottom. That's pretty easy to do with this, but this is just right at the bottom. Yes, sir.
Dave, is that a scroll bar tag marker, or is that just a graphics blurb, whatever, at the left side, right to the right of 613 on your clock on the screen?
This here?
Yeah, it looks like a scroll bar mark.
No, it's supposed to be the device's power button,
Oh.
right? See, like the volume buttons are over here, right? It's just the
Okay.
device frame.
Yes. Okay.
Yeah, nothing magic about that. It's just an image.
Okay.
Okay.
Sir, I have a question for you.
Oh,
you mentioned that this only works for, or it does not work for like linear layout and grid view, or sorry.
List view and grid view?
Grid view.
Right.
What about other views that consume scroll? Like, could you put a web view in a coordinator layout?
Not to do anything like this, no. So an easy way to make that determination, hop into the documentation, pull up nested scrolling child, which if I had internet I would do, and basically just look at all the views that subclass it or implement that interface. You're going to find a recycler view, something called nested scroll view, and maybe one or two others. Like there's not a lot there. But it has to implement that interface in order for this to actually work. Yes?
So those behaviors present themselves outside of the coordinator layout. So like if I have a recycler view and an app bar and I put it inside of that app bar layout, I put both of those in a relative layout, will that app bar start responding to those scroll?
Yes. I think what you're asking is, or at least what I'm gleaning from that, is that do they or don't they have to be direct children of the coordinator layout? And they don't. So I can have views with attached behaviors that are nested in other layouts. And that functionality does still work. So coordinator layout, when it's hunting for behaviors, does traverse like that. So is that kind of what you're asking?
Kind of. I guess another way of asking is outside of the coordinator layout, does the nested scrolling parent and the nested scrolling child, do they still interact, or do they need that coordinated layout around them in order to interact? So that nesting child is sending scroll events, let's say, and the parent's listening for scroll events.
Right.
Does that sending and listening only happen within a coordinated layout, or does it happen all the time?
It happens within any view that implements nested scrolling parent, which is pretty much coordinator layout, and another view called nested scroll view.
So that app bar layout was not a nested scroll parent?
Correct. Now, despite that fact, nested scrolling events don't have to be direct, again. So I don't have to have, like in this example that I had, I don't have to have the recycler view be a direct child of the coordinator layout. The recycler view can be nested in another layout, maybe even in another layout, and the recycler view events will still get to the coordinator layout. So you have to have one of each, a parent and a child. But where they live in relation to each other is they don't have to be directly one underneath the other. They could be nested as long as the parent is an eventual parent of the child view. So that you can do. Okay.
Did you implement like on a relative layout? Can you just go ahead and implement nested scrolling parent?
Yes, you can. It's a lot of work.
Okay.
But I guess the point is that it's not just maybe a handful of methods you override and you're done. You might be able to get a little further with views that already handle scrolling internally, and you just have to listen for those events. So one thing you could try, this is just off the top of my head, is list view supports scroll listener. You might be able to get away with dispatching nested scrolling events from a scroll listener. And that's not going to get you all the way because you don't have the pre-scroll part of it. But you could essentially override any view you like and do this. It's just your responsibility to dispatch those events at the right times. Typically, that means you're also actually writing all the touch code to implement the gestures associated with those scrolls. So if you can get away with doing one without the other, and you can get yourself into that hierarchy such that you can dispatch a pre-event before the actual scrolling happens, then you could put this on any view you like, yes. But you're going to have to write that code. Good question. Okay. All right, so in this example, and then I'll show you the other ones. In this example, notice that just like with the app bar, this is following the scroll. So, I mean, no matter what distance I scroll, it's moving by the same amount. Okay. So, and that's just because that's the default behavior of app bar, so I mirror that on the other side. Okay. I've got another example that I'll show you briefly, because I want to show you all of them before we get to the code, that I call a quicker return. So in this case, we're actually using an animation to trigger the difference. So when we scroll up, the view as well as the action button actually animate out of position. So they move much faster because they move immediately, regardless of how far I scroll. Right, as soon as I cross that threshold, they're gone. Okay, and then similar on the way back. When I cross that threshold again, they'll move back in. Right, so this is you could still call this a quick return. This is more how Google Plus does it than some of the other apps where they pop out of the way and then pop back in. So sometimes you'll see them follow, which is the default, and sometimes you might see this behavior. So I kind of wanted to show you both of those. And they're both of those examples are fairly simple to do. Right? There's not a whole lot of code that goes into either one of those. It's not too bad. The last example that I have is crazy sauce. This one I probably won't have time to go through all the code because there's a fair amount. But this is something, it's actually something I had to write for a project a couple years ago, back before all this existed, and it was a nightmare. And I wanted to see if I could re-implement the same thing with coordinator layout and it not be so bad. And it was actually much better. So the premise here is I have a couple of views inside of a coordinator layout that I'm calling cards. But basically these are all views that are overlapping, and I can actually pull the card views down one in front of the other to reveal the other ones in front. Right? So each one of these has a scrolling view in front of it, a recycler view, but then as I scroll down beyond the top, it'll start pulling the card view down to reveal the one behind it. Right? And then I can do that with this one, and it'll reveal the one behind it, and so on and so forth. Right? And then I can scroll them back up, and as they're scrolled down, I can't scroll the contents of the recycler view, but as soon as they reach the top, then the recycler view starts to scroll. Right? I had to do this before this existed, and I hated myself. I got it to work, but it was thousands of lines of code. Okay, I implemented this with a coordinator layout behavior in less than 200 lines of code. Okay, so the nested scrolling behavior and all this stuff helps a ton. Okay, and it allows me to create this sort of behavior where these cards are dependent on each other too. So if I scroll this one down, and it'll push the other one out of the way, and you can scroll them all around, and you guys can play with it because it's on GitHub and all that stuff. But this is a much more complex example of using behaviors to control dependent views on each other. And actually, there are some cases where some of these portions of the behavior aren't actually using the framework. So like the behaviors where these views can push each other around, I actually had to write that myself. It's in the view behavior, but it's not using view dependency like as part of the framework. It turns out there's some weirdness when you try to add too many dependencies to a given view, and those are all circular, which is kind of what ended up happening here. Every view depends on every other view. It didn't like that too much. So you kind of want to keep those things fairly simple, and since that wasn't the case, I had to kind of manage that myself. But other than that, I pretty much leveraged the API for everything, all the scrolling bits and all the moving pieces and all that. So this is another example of nested scrolling. Right? So the nested scrolling is allowing me to control that using that pre-scroll callback, if my card is not at the top, I want to consume that scroll for the purposes of moving the card. But as soon as it's in the right place, I don't want to consume the scroll anymore. I want to allow the recycler view to actually do what it does best. Okay, so this is a more complicated example that's focused primarily on nested scrolling. It does use layout behaviors a little bit because we actually use the layout callback to stagger the cards initially. It basically figures out where the previous card was to lay the next one out next to it. It does all that in the behavior. But other than that, it's almost exclusively nested scrolling stuff. Okay.
Can you reveal any of those cards without scrolling?
How do you mean? Like if I just clicked on one?
Yeah.
I didn't implement that, no. It'd be fairly straightforward to do because the code's already there. I just have to handle that tap event and animate it down, but it's not in there. I wanted to keep it more focused on the behavior bits, and that would sort of be additional bits there. Okay, so what I'll show you just real briefly are the two simpler examples because they're easier to walk through, and then that should give you hopefully enough of a concept of what's going on to give yourself the courage to dive into the more complicated one and sort of look at that on your own time. All right, so the scrolling footer was the first one. So let me bring up a couple classes here and then I'll hide this bar so we can look at it. All right, so the scrolling footer example looks very similar to the simple one that I had. The only difference is I've added a new custom view at the bottom called a footer bar layout that has, in this case, just a text view inside. I could stick whatever I want in here. The idea is just like with app bar layout, anything I stick in here is going to be moved around because that container is responsible for that interaction, and anything I stick in there is sort of irrespective of that. So I've created this custom footer bar to sort of behave like the app bar does at the top. The footer bar itself doesn't do much. It doesn't have any code in it really. I'm simply using it as a way to explain or to show how to attach a default behavior. So the behavior associated with this is attached in Java code using that annotation, which is why I don't have any behaviors in here in XML. So by using this footer bar layout in my coordinator layout, it just always has the same behavior attached because I don't have to put anything different. It uses the default that's attached using that annotation. And then the behavior code handles the rest. So this behavior is fairly straightforward. It has a single dependency on the app bar layout. So every time the app bar layout changes, the footer bar is going to get a dependent callback that we can use to change it as well. So in onDependentViewChanged, all I have to do is figure out, okay, well, and notice what's passed into this method first of all. So we always have the parent view, the child view we're attached to, and the dependent view that changed. Okay, so the dependent view is the app bar, and the child view, the footer bar, is the one we want to manipulate. So all I have to do is figure out, okay, has that view moved from the last time I saw it? And if it has moved, how far has it moved? And I need to offset my view to match it. So all I'm doing is observing one other view that's already doing what I need. It's already scrolling out and coming back in at the right times. Rather than re-implementing all that behavior, I just watch it. And then as it moves in and out, I move mine in and out, and essentially in the inverse, so that the two mirror each other exactly. Okay? Not too bad, right? Pretty simple. The only other reason I have on layout in here is to get the initial value of that so that I can use that for comparisons, because the offset method is not an explicit, like, set it to this value. It's shift it by from its current location. So I use that to determine what the actual delta is so I know how far to shift it. Okay, but that's it, right? All of 70 lines of code. Take out the comments, it's probably less than 50. All right, so not too bad. Okay. So then we have the example of the animated return, which I call the quicker return. So in this case, what I've created is a similar layout. Again, the layout is exactly the same as the simple one. But what's different in this case is now the app bar layout and the floating action button have a custom behavior attached to them, called what I call the quick hide behavior. Okay. So the app bar layout, and actually another thing to note, because the app bar layout is no longer observing those scroll events directly, I don't actually need that custom behavior on the recycler view either. So I could take that away. But since both of these are doing the same thing, I just use the same behavior. It's just applied to these two different views. So the app bar layout's going to quick hide, and the floating action button is going to quick hide. Okay. So what does quick hide look like? It's a little bit more code, but it's still not too bad. So in this case, the quick hide behavior is interested in scrolling. It wants to observe when the user scrolls that container. And if we scroll above a certain point, or really what that means is you scroll a certain distance, because it doesn't necessarily matter whether we're at the top or the bottom of the view. As soon as we scroll past a certain distance, we want to trigger that hide or show behavior. Okay. So I do have some extra code in the constructor. The only reason is because we're defining the threshold as half the height of the action bar. So I want to get the action bar as whatever its current value is for the theme. So I'm just doing that in the constructor so I get it once. So whatever half the action bar height is, that's the distance you have to scroll to trigger this animation. So then we implement just a handful of those scrolling callbacks. On start nested scroll, this is how we declare interest. Right? The scroll is about to begin. Do I care? Well, in this case, I care so long as it's a vertical scroll event. Remember, recycler view can scroll vertically, horizontally, or both. I've got other examples on that if you want to see that. But I'm only interested in vertical scrolling. So assuming that this event happens to be a vertical scroll event, we're going to say, yes, I care. Okay, so give me further information. Then we use nested pre-scroll and nested scroll to determine when we've reached those thresholds. Okay, so in this case, I'm using pre-scroll to observe the events, but I'm not doing anything with them. I'm not consuming the scroll event or anything weird like that. I just need to know at this point before the view actually scrolls whether the user is moving up or down or anything like that. I use this to determine when they've changed direction. So if they were scrolling up and now they're scrolling down, I kind of need to reset how far they were scrolling. Okay, that's all we're really doing in here is tracking some state. But then in the nested scroll method, which tells us exactly how far the method or the recycler view is scrolled, then we're going to determine, we're accumulating those distances and say, okay, now we've gone beyond half the action bar height. So if we're scrolling down, that means we need to hide stuff. Or sorry, if we're scrolling down, we need to show stuff. If we're scrolling up, we need to hide stuff. Okay? And that is just done with an animator. So there's nothing magical about that. It just uses object animator to translate them out of the way. Right? And it determines where to go based on whether it's the app bar layout or the floating action button. So the app bar layout goes up, the floating action button goes down. Simple as that. Yes?
So how does all this tie into like the life cycle for the view or the activity? If you're going to on pause and you're dead in the middle of the end, like you change orientation, you're dead in the middle of an animation. Does this stuff have hooks into the Android lifecycle also, or do you have to manage that?
So there is a save and restore state callback. So if you, when you really get to that level of detail, then you would use those to persist maybe, current state of where you are in either your scrolling position or if you're offset with a view or you've animated it away so that when you bring in the new view, you can restore that state. So yes, there is an on save and on restore instance state callback on behaviors.
So you're just using all the view group stuff.
Right. Right. So there's no magic about it. But the facilities are there so that you can implement it all in the same place. Yes?
Where do we establish the relationship between the fab and the app bar to track the scrolling?
Sure. So in this case, there is actually no relationship between those two things. There's a relationship between the fab and the recycler view and the app bar and the recycler view. Now, in this case, there's not a direct relationship because the behavior only cares about scrolling events. So it only has to indicate that it is interested, where did I go? There it is. It is interested in nested scroll events. Because the fact that there is a recycler view in the coordinator layout, all of its scroll events are broadcast to all the behaviors because it's a nested scrolling parent and a nested scrolling child. Because those exist, that communication is happening under the hood. And we get these callbacks to allow us to determine if we're interested in them or not. So I don't have to say that this behavior depends on the recycler view. I just have to observe. That's kind of what I'm doing here. Here I'm saying I'm interested in scroll events, which sort of locks that relationship to say, okay, when this thing scrolls or when anything scrolls, you're going to know about it. So that might get a little complicated if you have multiple scrolling views in the coordinator layout. That's where these other parameters that I'm not really using come into play. This is where it'll tell you exactly which view is scrolling and what the parent of that view is. And so you can make some of those decisions about, oh, is this the scrolling view I want or not? So this is sort of like layout depends on for scrolling. You just do it more based on the scroll events themselves than the actual explicit views in most cases. Good question. Okay. So inside of these pre-scroll and scroll events, the way that this relationship as far as events being consumed happens is using these parameters. So again, in a pre-scroll event, this dx dy is going to be the distance of the scroll gesture. This is how far the finger moved. Okay, and since this behavior or this parent has the opportunity to see that first, the parent can tell the child how much of that scroll it has consumed. It does that by filling in this. That array is an out parameter. Okay, if you've never done custom view work before, this is a little weird because Java doesn't do it a lot. But this is a parameter you write into instead of returning the value back. Okay, so there's no return value here, but this is a two int array for x and y, and so you would set the value of this array to be the distance you consumed, and then that will get fed back into, in this case, the recycler view, so it knows how much is left over for it to do its own work. Okay, so when you report that back, you report it back by filling in this array. I don't do it here, but in the sliding cards example, I do. So you can see how you fill that array in when you want to consume the event versus let it go. Okay. Then on the nested scroll, you get two pairs of values. You get dx/dy consumed and dx/dy unconsumed. So again, this is after the recycler view or the scrolling view has scrolled, based on, again, that gesture, how much of the scroll did the recycler view use up, and how much is left over for you to do something extra with. Okay, so again, this is where over scroll behavior would come into play. So if I go back to my fancy example, as I'm scrolling, oh, I'm at the bottom, that's why. As I'm scrolling down, the nested scroll in this case is consuming everything. So that dx/dy unconsumed is 0. But as soon as I start hitting that top part where the recycler view says, oh, I'm at the top, then that scroll event instead comes back and says, well, it probably used part of it to finish the scroll, but the rest was actually unused. And in this example, if you look through that code, it's taking that remainder and starting to move the card. Okay, so you can get it before and after to be able to create this smooth experience with a single gesture. Okay, pretty slick. I like it.
That API is kind of funny. So can you think of any reason why they didn't use a consumed array on that method?
Why they didn't do it here?
Consumed and unconsumed array?
The only thing that I can think of, and this is me trying to speak for Google, which is always a really bad idea. The only thing I can think of is that traditionally in the UI toolkit, when out parameters exist, they're primitive arrays. And if they're just, because essentially an int array is an object, these primitives are not. So I can't set the value of this without actually changing the reference. With an object, I can write into the value in the array, but the reference to the array object stays unchanged. So I think it's more about being able to modify the values of an object, whereas a primitive, I'm actually moving references because those aren't actual objects themselves. But again, that's me trying to, there may be a better reason. That's just my guess. So typically, you see this in a lot of the custom touch interactions as well. What's the other one? Like drawing, you get an out rect for putting stuff. If you want to take a view size and modify it, they say give me a rect and I'll put the values in there so you're not allocating new objects all the time. So this is that same idea where they end up reusing the same array over and over again through each iteration. So they don't have to keep allocating it, but they can use a single instance passing back and forth, which they can't do with primitives. So just a guess. Okay, so again, I won't go through the code, but I'll just show you that the other bits in this example are the sliding card layout, which is the layout that represents that card I just showed you. So this is partially just a customization so that I had one place to put the header bar, recycler view, set title, color, all that mess. Just putting it all in one object here. The interesting bits are going to be in sliding card behavior. Okay, so this implements the observing of the scroll events, sliding of the cards, shifting of the sibling cards around when they bump into each other. All that stuff is in here. Okay, and like I said, I did the whole thing in 270 lines of code. Okay, it took a lot more than that before. So this is pretty slick API. So you can spend some time kind of on your own and look through that. If you have questions, obviously feel free to shoot me an email or ask me a question on Twitter or Google+, whatever you want. I'm happy to answer that. But this stuff is all on GitHub, so you can play around with it. Which brings me to the slide that I skipped. So if you want to find out more information, again, Mile High Android, that's my GitHub stuff. And this example, along with tons of others on custom views, beacons, and all other weird things that I do with Android, you're going to find on that page there. So you can, but coordinated effort is the one you're looking for that I just showed you here. It's going to be at the very top of the page. So you can look at that, play around with it. And then there are some other examples of just using the design support library in general. There's the video they did to introduce the design support library. And then there's Chris Bain's sample chi-square, which is basically here's all the intro you need to get up and running with design support library. So there's some coordinator layout stuff in there that you can draw from for more of the standard common patterns as well. Okay, so that's all I got, guys. If you got more questions, I'm happy to answer them. Otherwise, thank you for your time.